Hi, everyone, and welcome to today's webinar, The Synthetic Data Promise Gap. Thanks for joining us. Before we get started, I have a few quick housekeeping items. All attendees are currently in view and listen only mode, and we'll be saving time at the end for Q&A. And we encourage you to submit questions throughout the session using the Q&A button at the bottom of the screen. We do have the chat also open, so if you want to connect with one another or add commentary during the discussion, please do so. So let's start with introductions. I'm Jen Longo, Senior Vice President at KS&R, and I spend my time helping clients use research and insights to inform business decisions, drawing from both qualitative and quantitative methods. One of my main focuses is working with clients in the telecommunications and entertainment sectors. And joining me today is my colleague, Ben Cortese. Ben, I'll turn it over to you for an introduction.
Thanks, Jen. I'm Ben Cortese, SVP of Decision Sciences and Innovation here at KS&R. I've been with the firm leading quantitative research for about 10 years now. And for the last 3.5 or so, been really focused on AI strategy. And even more recently, with the boom of synthetic data, have really been focusing on what it all means and how we can all be reacting to it and its implications in the field. So I'll turn it back over to Jen to get us started.
Thanks. So, before we dive into the content, I'll share what you'll take away from today's session. So, we'll start by looking at the current landscape. Synthetic data is getting a lot of attention right now, and we'll share what insights teams are asking for today so that you'll have a more realistic view of where the market stands. From there, we'll talk about the promise gap. So, this is the difference between what synthetic data is often marketed as being able to deliver and then what organizations are actually seeing in practice. We'll then turn to governance. As adoption grows, the challenge isn't just generating synthetic data, but it's knowing how to evaluate it. And so we'll introduce KS&R's Echo Index and share our perspective on building a more transparent and consistent framework for assessing synthetic data quality. And then based on what we've learned through our own work, we'll share some considerations to help you make more informed decisions about where synthetic data can create value and then where caution may be warranted. So to start, I recognize that organizations may be at different stages in their synthetic data journey. So we're going to launch a quick poll. So through this poll, if you could please tell us where you are in your synthetic data journey, we'll give everyone a few moments to respond. All right, looks like we're getting a decent mix of responses in. So it's good to see a mix of experience levels represented today. We got about 40% just beginning to explore synthetic, and then the range is up to just under 10% actively using synthetic. So a wide range of the spectrum, and our goal today is to provide insights that are valuable regardless of where you are on that journey. So now that we have a sense of where everybody is in their synthetic data journey, let's start with what we're seeing in the market. So synthetic data has moved beyond being a niche topic. It's now showing up in leadership meetings, budget discussions, vendor conversations, and in strategic planning sessions across the industry. And oftentimes these conversations are happening faster than the evidence. So everybody is under pressure to solve synthetic. On the client side, when I speak with many insights leaders, myself and others across KS&R, clients are telling us that they're being asked about synthetic data by their senior leadership. They're hearing claims about lower costs, being able to get instant results, and AI replacing traditional research workflows. So naturally, they're asking their teams, should we be using synthetic data too? At the same time, panel providers are trying to determine whether synthetic data represents a threat, an opportunity, or both. Market research agencies are feeling pressure from clients who want answers, even though many of the use cases are still being tested and validated. And then you have AI native startups. They're entering the space with technical expertise and speed, but often without decades of experience in survey methodology, sampling, or research design. And so, what I find really interesting is that opinions about synthetic data span the entire spectrum. Some people believe it's the future of research. Some people think it's overhyped. Some think it will fundamentally transform insights. And then others think it will be useful, but only for a handful of narrow applications. And I think, if we took another poll just among this audience, we'd probably see all of those viewpoints represented. And the challenge is that the loudest voices are not always the ones with the strongest evidence. And right now, there's a tremendous amount of positioning and marketing and prediction. And there's far less rigorous discussion around where synthetic data actually works, where it struggles, and how we should evaluate success. And that's what we want to focus on today. The conversation isn't about whether synthetic data is good or bad. It's a conversation about separating what's proven from what's promised. And so, as we worked with clients at KS&R exploring synthetic data, we've begun to notice a pattern. And the pattern is the starting point is often very broad. So I'll give you one example. A conversation might begin with a client saying, we want to use synthetic to brainstorm new product ideas, rank them, and then tell us what the winners are. And that's an understandable ambition, but our question is then, okay, what data do you have to train that model? And the answer from the client is, we don't have anything that can do that, but we do have that large tracking study that you manage for us. Could that be all synthetic? And so at that point, the conversation really shifts and we start talking about the business problem they're trying to solve for the tracker. And through those discussions with the client, the objective becomes much more specific. And the client says, we're completing thousands of interviews every month. Those dollars could potentially support other initiatives. We also have some important but small target segments where we'd like greater confidence in the results. And so now we're getting somewhere, right? Through those conversations, the question is no longer, can our tracker be all synthetic? But the question becomes, can synthetic boosting reduce sample requirements while maintaining confidence in the findings? And can synthetic data help us better understand small audiences that are difficult to reach? And those are two testable questions. And that's really the point, right? The bigger predictor of success is having a clear and narrow objective. And when there's vague goals around synthetic data, that's what tends to stall the process. And so having specific goals creates a clearer path forward. When I think about it, I often compare it to segmentation work. And nobody expects a segmentation study to be perfect on the first pass, right? You expect iteration, you refine variables, you revisit assumptions, you tune the model. Synthetic data is similar in that the best outcomes come from treating it as an analytical process and not a magic button. It's best to start small, define success clearly, test, learn, and iterate. And this brings us to what we're calling the promise gap. In many cases, the expectations of synthetic data that are being set in the industry are running ahead of the evidence available today. Here are a few of the most common claims that we're hearing around synthetic data and then what we're seeing in practice. The first is speed. You'll often hear that synthetic data reduces fieldwork time. And the reality is that models still need to be built, trained, and evaluated. And the biggest gains are often realized after you've already invested time in the setup and on repeat studies. The second is cost. You'll hear that synthetic data is much cheaper than human data. And that's not always the case. It really depends on the methodology, the training requirements, and the underlying technology, and costs can vary. The third is quality, and this is perhaps the boldest claim that synthetic data can produce better insights than human data. And we have to remember, synthetic data is derived from human data. We should be skeptical of claims that synthetic data somehow exceeds the quality of the information used to create it. And then novelty. There's a lot of excitement around generating entirely new insights, and the challenge is that novelty and accuracy often exist in tension. So the further we move beyond observed reality, the harder it becomes to validate what we're seeing. So, none of these observations mean synthetic data lacks value. What they mean is that leaders and researchers should approach claims with the same rigor that they would apply to any other business decision. So I'll turn it over to Ben now to discuss the evaluation and governance of synthetic data.
Great. Thanks, Jen. I want to get started with an eye chart here, ultimately to demonstrate what we mean by synthetic data in some of the applications. Synthetic data probably means something different to every one of you in attendance, and that's one of the main hurdles with this technology. And so, as we start to think about synthetic data, right, we have five different methods that are viewed as applications that we want to tee up to get everybody on the same page. So first, we're going to start with synthetic data that actually requires no generative AI at all. And so hopefully clearing up some misconceptions about what's required and what's not to land on these particular models. So first is extrapolation. This is something that is not new. It's ultimately a statistical technique that lets us go beyond the range of data or values tested within a particular model. Not super reliable, but is something that comes out of a statistical model. Therefore, it is synthetic data. Interpolation is similar. So interpolation allows us to fill in missing pieces within a data set. Typically, those that are run by some sort of design intentionally to drive random missingness. However, we often use it in other cases as well. And this is a highly reliable and measurable technique that's been adopted for decades. And so this also does not require any generative AI. Ultimately, deep learning, machine learning methods do a fine job with a majority of interpolation. Then we get to sample boosting. This is probably one of the terms a lot of you have heard and think about when we're having the synthetic data conversation. Sample boosting is ultimately using the same tech that drives interpolation, but applying it to a different problem. So ultimately, sample boosting is creating new respondents from these predicted models that didn't exist in the original data set in an effort to try and have a better understanding of niche audiences or boost your sample size, etc. One key thing to keep in mind is that if we are not leveraging Gen AI for sample boosting, we cannot go outside of the information that we used it to train on, unlike some of the other models we'll talk about in just a minute. Here, this is moderately reliable. We're going to get into a lot of why that's the case during the rest of this discussion today. Right. Then we get into turning generative AI on and leveraging large language models or LLMs to be able to create novel insights. So digital twins are the quantitative leaning version of synthetic data when it comes to generating one-to-one matches to a person, a system, a process. Ultimately, these are designed to behave, respond, and provide information as though they were the actual person that the twin is representing. So there's a lot of these models that can ultimately duplicate the respondents in your data. Confidence here at this point is low. There's not a solid validation mechanism in place to be able to truly tackle this in a way that the industry has adopted. There are some great use cases and applications for digital twins, though. So I'm not discounting the approach. Just calling out that when we're using these types of tools, we need to be very mindful of the applications and the risks that we're taking on by using insights generated from these specific models. Then we start to skew pretty far into the qualitative side when we get into synthetic personas. Here, we think about these as a group of digital twins. So ultimately, it is a representation of a broader group or audience that we can then ask questions about, let's say, a segmentation study. We have synthetic personas that represent each of our different segments. That allows us to extend the research and ask targeted questions beyond what we had in the original questionnaire to be able to get some new insights that are adjacent topics to what we've learned from the segmentation, for example. Similar to digital twins, validation is difficult, and so confidence in this space, again, is reasonably low. However, we can think about these as opportunities to, do rapid iteration, early stage message testing, other things that allow us to take larger lists or larger sets of ideas and reduce them down further before we go into traditional human research. So this visualization we found can be really helpful when we're thinking about framing the sample boosting versus digital twin problem. So in the upper left here, we have our real world data, or the data set that you would typically use for a traditional quantitative research study. Then when we think about sample boosting, right, we have this green area here below it, which is adding new rows to that data set, doesn't require LLMs, and ultimately helps us, if done well and successfully, either bolster our sample size or be able to report out on smaller segments that we otherwise would not have been able to reach. Then in the upper right, in the purple there, we have digital twins. So this is adding new columns to your data set. The key difference between sample boosting and digital twins is ultimately that sample boosting, typically, especially if you're not using Gen AI, regenerates or predicts information that's the same structure and the same format as the training data or your original data set. Digital twins are much more flexible, right? They can create qualitative data through conversations. They can create net new columns to help extend studies beyond what was in the questionnaire. But ultimately, there's no real world data to compare back against, which is where sample boosting with adding additional rows, it has a leg up in terms of evaluation and governance. Then, if we think about combining these two ideas into synthetic audiences, ultimately being able to train some series of models to respond to net new information that's outside of the context window in a completely new topic, these tools are there. They exist today. Not recommending that they're used for anything other than early stage pilots and experimentation. These are nearly impossible to validate. And the best way that we found when it comes to investigating these is to have conversations with those vendors that are providing these services to try and see how much transparency you can get out of those processes. But from a pure governance and evaluation standpoint, not something that we even have the tools to evaluate today. And so, that leads us into some of the things that you might see as you are diving into synthetic data and evaluation in terms of tricks or strategies that ultimately fuel this promise gap that Jen had mentioned. So we've got a handful of these strategies on the screen here, but there are more beyond just what we have. Just to give you a kind of brief example and overview of some of the things you'll see. So the first is a really narrow evaluation. So oftentimes you'll see, our synthetic data was able to preserve correlations. Well, that's one metric. That's measuring the relationships between different questions and ultimately leads to the success of downstream analysis like key driver analysis or other advanced modeling. However, there's a lot more that needs to be covered when it comes to evaluation of synthetic data. And leaning on a single metric is not sufficient in terms of that evaluation, as we'll showcase later on today. That gets us into cherry picking. So ultimately running a bunch of different tests and seeing which one works the best for your synthetic model. And this is not a statistically valid way to go about understanding how well your synthetic data aligns to real world data and ultimately can produce results that look really promising to be able to share with your stakeholders that your models are working well, despite the fact that you haven't actually provided the full picture or the full story around the evaluation that occurred. The third is metric maxing. So ultimately similar to the first two, but instead picking a evaluation criteria, let's say KL divergence or some other distance measure, and really fine tuning your model performance to beat that metric so that you can have really strong scores for a specific benchmark. And then ultimately make claims that your synthetic data works across the board because you focused on one specific metric. So this really kind of feeds into the question of we've gotten away from letting your ad agencies test and self-evaluate their own ads they've produced. So why, as an industry, are we going down that same path and allowing that for synthetic data providers to be able to self-evaluate without having some sort of third-party governance or framework that we've accepted as a whole? So, we're here today to talk about KS&R's development and approach to governance and how we think about adding structure and formality around this space. So we've developed the Echo Index, which is ultimately a mechanism to evaluate sample boosting. Many of you, I'm sure, were expecting this to apply to digital twins, as that's been a very, very popular term. So we'll get to that in just a minute. But ultimately, we started with sample boosting because, as we talked about before with other synthetic data methodologies, sample boosting is leveraging the similar technology as imputation. We have validation and evaluation tools, techniques, and strategies in place to verify that type of application. And we can extend those in a meaningful way to sample boosting pretty naturally because we have a real world data set to compare to be able to measure the similarities and differences in what that synthetic data is bringing to us. When it comes to digital twins, There are strategies that we can still apply the echo index in this framework to. However, it requires more of a research on research technique. One of the benefits of the echo index is that it applies to any standalone data set. So we can actually measure the effectiveness and alignment of synthetic data, regardless of the source, as long as we have a real world counterpart and the synthetic data itself. Digital twins don't allow us that same flexibility because we don't know what the answer should have been unless we have a standardized benchmark study that we run and ultimately hold out questions to go ahead and verify. And that can have varying levels of success in terms of how those types of benchmarks are structured and what we're looking to test. Um, so with that in mind, we'll get into what the echo index is and how it performs against a couple of publicly available data sets. So ultimately, the echo index measures how close the synthetic data is to the real world data that it was trained upon. Um, we look at two different components of evaluation, ultimately leaning on the statistical components. So I had mentioned KL divergence. We've got a handful of other distance and divergence metrics that look at univariate or a single question. And how does that single question look from a synthetic standpoint versus the real data? And are they close? Or are we introducing things that we wouldn't expect from that synthetic data? Beyond just single questions, we also want to make sure we are preserving the relationships that exist across the data. And to do that, we need to look at bivariate relationships. And so here we cover things like correlations across numeric questions, Cramer's V, the phi coefficient, depending on the data structure we have, to ensure that those bivariate relationships are preserved so that when we look at downstream analytics and we apply any sort of statistical or data science techniques, we have those relationships and we haven't lost the signal within the noise. Then we have also found statistical measurement isn't enough, and we'll talk about that in a little while. Ultimately, we need a second lens at which we bring in a machine learning classifier. And so here, ultimately, we test to see if a machine learning algorithm can correctly predict which data is real and which data is synthetic. And we use that as a measurement to understand if we've left behind any artifacts within our synthetic data that we otherwise wouldn't have noticed with our statistical review. I had mentioned the echo index applies on any standalone data set. And so ultimately here, the reason why is because first, we take the real data only and we run our process on that real data set many times by partitioning it into two and running the echo index. That gives us an understanding of a benchmark for that specific data set. Benchmarks are going to be different depending on the data, the number of columns, the number of rows, etc. That gives us a benchmark that applies in a vacuum, which is really helpful so that we can draw accurate comparisons about the synthetic data. Then we fold in the synthetic data and we run the echo index again, comparing the synthetic data to the real world data, the full data set. And this score gives us our echo index that we can then use to measure closeness to the real world data. And ultimately, we look at that baseline distribution. We look at the synthetic data score and we calculate an effect size, which gives us a single number that quantifies confidence in how close the synthetic data was to the baseline distribution. We've presented this to the community at the Sawtooth Research Conference in Berlin in early May, and gotten a bit of feedback about the novelty and the utility. And we're going to share some of the similar findings about how this applies to various data sets. And so here we took a look at two publicly available data sets. We have a study from Paxton and Yang, which is really designed to be a simple, achievable study. We wanted to see, in a very rudimentary sense, can synthetic data effectively look like the real counterpart. So with this study, this was an 11 question study, had 8 agreement scale questions and 3 demographics. Really, really small, probably not applicable to a lot of the research that we're all doing. But again, we were looking for something that we hoped would actually be successful. Then on the other hand, we looked at the Twin 2K 500. So those of you that are building digital twins, you may be familiar with this data set. Ultimately, the purpose of this is to replicate a big, ugly, nasty market research study where just over 2,000 people were asked 500 questions over the course of several sessions and hours. And ultimately, that creates a data set that's very, very large and unwieldy. I think over 700 columns altogether when we look at some of our variable mappings. So we have the bookends. We have something highly complex, something relatively simple. Then we ran three internal models from KS&R, a VAE, a GAN, and a Gaussian copula. Important note here that none of these rely on Gen AI or large language models. These are all machine learning or deep learning techniques. So we don't have any of those traditional concerns about LLMs. Then we had some pay-to-play third-party vendors that participated as well. And we'll go ahead and showcase the performance across these different models on these two data sets. We're going to evaluate this two different ways. We're going to evaluate with the Echo Index and that framework that I just discussed and outlined. But we're also going to use some traditional metrics. And I think that's important because we are making claims that the traditional metrics and statistical validation alone is not enough. And we want to make sure that we are justifying why we're making those claims and showcasing some instances where maybe they do align and others where it's just not sufficient. For the purposes of these exercises, the synthetic models were used to double the size of the original data. So for the Twin 2K500 study, we had those 2000 plus. We're going to create 2000 plus synthetic. Same thing for the Paxton and Yang study. So we're going to start with the simpler problem. Ultimately here, again, we were looking for something that would be successful in terms of running synthetic models on a smaller data set. And so first, on the left-hand side, we have our models. Then we have our traditional metric evaluation from SD Metrics, which looks at similar components that the Echo Index is considering when it comes to that distribution preservation as well as relationship preservation. Here we can see we have one model, the VAE at 0.87, pretty close to 0.9, and then two models, the Gaussian copula and vendor D, well above 0.9. And so those generally show promise in terms of their ability to replicate and look like that real world data. Then we have the Echo Index, and you'll see the baseline here was 0.02. I don't have the standard deviation up, but you can back into the standard deviation of that distribution via the effect size calculation if you're curious. So here we see some catastrophic failures with some of the models that we ran, but then we see some success with one of the vendors. Ultimately here, we're considering success as an effect size that has an absolute value of 3.5 or less, which in this case is 3.5 standard deviations or less away from that baseline mean that we created as we were building the index. So ultimately here, we did. We were able to identify a vendor that was able to successfully reproduce synthetic data that looked close enough to the real data to pass through the Echo Index, which was great. Hoping that this gives us some confidence that synthetic data does actually have utility in our industry. Now we're going to move on to the hard one. So the Twin 2K500 here, similar table with our models, different vendors. Here we were only able to evaluate three of the models with traditional metrics. However, you see really strong scores again, right? All of these metrics in the ballpark of 0.9 or higher, indicating, hey, we've got something here. We can use this. Let's move forward and let's go ahead and make some decisions based off of the synthetic data that was created. Not so fast though, right? When we look at the Echo Index and the effect size calculations coming off of that, we start to see we have some real problems in terms of aligning and looking like that real world data. And this happens for two reasons. The first reason is that there's a lot of single select demographic questions in this data set. And we found time and time again that single selects and multi-selects are very difficult for synthetic data to correctly and accurately be reproduced and look like the real data. So the success on the previous Paxton and Yang study shouldn't be a surprise because the primary vehicle of measurement were numeric or agreement scales. And the other component here is those machine learning classifiers. So ultimately, we found that nearly in every one of these cases, the machine learning classifiers were able to correctly predict the synthetic data from the real data nearly 100% of the time. Didn't matter which model, didn't matter which vendor. Ultimately, across our classifiers, there were significant artifacts left behind indicating which data was synthetic and which was not. So this showcases how just reporting out on statistical similarity can be a huge challenge. Even though it looks really good from a marketing perspective, we need to be diligent about how we are viewing evaluation when it comes to synthetic. So to sum it all up, right, the traditional scores looked really strong, but the Echo Index actually tells us a more honest story. And I did allude to the fact that we were able to figure out single selects were not performing well, multi-selects had trouble. We can dig in at the question type level as well as at the individual question level to then recommend how well different questions themselves are synthesizing and if we expect to have to drop any variables or do further tuning to our models to ensure that we have success even at the question level. So it gives a nice roadmap of how to move forward. So ultimately, what we found is that if you have a simple data problem where you have a relatively small data set, a few KPIs, and you want to boost that for getting access to target audiences, or ultimately you want to collect less data on one of those sections, then ultimately, if it's simple enough, then synthetic should be able to reproduce reliable results, which again, you can measure via the Echo Index or any other evaluation technique. Just make sure that you're keeping an eye on how you're actually evaluating. When it comes to big, ugly, traditional market research studies that have complex data, skip patterns, and all sorts of different question types and logic, we can still see strong performance of traditional models. However, the Echo Index enables us to cut through that and really get a better view of confidence, as well as a way to explain how close our models are, or how close the synthetic data is to the real data, so we know what level of risk we're willing to take on based on the decisions we're going to be making by leveraging this data. So, keep in mind as you're having these conversations, and many of you are just exploring what synthetic is, it's really, really important to ask really detailed and specific questions about how the data is being generated and how it's being evaluated to make sure that you have a solid understanding of what you're taking on when it comes to decision making within this new world. So with that, we want to wrap up with some practical guidance on what we've seen across all of our investigations and research to date. So really, we did see some success, which is fantastic. I've been a staunch skeptic for quite some time when it comes to synthetic data, and seeing that we were able to successfully have some vendors complete the Paxton and Yang alignment test via the Echo Index was promising. And that ultimately tells us some of the models work really well and others don't. And I think that's one of the key takeaways is that we really don't need generative AI techniques when it comes to sample boosting. The technology that's been around that drives imputation and has now been reapplied in a sample boosting framework is really fantastic, and it does work really well. We've been working with vendors that do both Gen AI and just traditional deep learning when it comes to sample boosting. And there's also, a cost component that comes into this too, where the traditional data science is not, you have to pay for tokens. So there's no additional costs that you incur versus those LLM-based models. The second, I already discussed this, is question type. Numeric or quasi-numeric questions like agreement scales or Likert scales tend to perform really well when it comes to synthetic generation. Single selects and demographics and other questions tend to just be out of alignment. And so we can and we have seen success with some of these just with iteration, as Jen had mentioned, right? Going into this thinking it's going to be an easy button, it's going to be fast. That's generally not the case. It takes time to tune these models to get to a place where we can have confidence in what they're actually generating and creating. Then we see there's no real rule of thumb, at least that we found, when it comes to base sizes. We do have early indicators that subsegment boosting seems to be a really, really promising space. Ultimately, if you have less data, you have more variability, and there's more room for fringe cases and filling in the gaps with these types of models than if you have 2, 3, 4,000 completes. And so when you're thinking about applying synthetic data in small sample size areas, it's a good place to start. However, just keep in mind that you are working in an area where you have more volatility. So you should just trade that off of with the types of decisions you're trying to make from that data. And last, this iteration piece is huge. All of the studies that we've done to date have been really collaborative with our clients, as well as with anyone who is providing synthetic data, iterating back and forth, agreeing on things that we should or should not synthesize to ultimately get to a place where everyone is comfortable and happy with the data and the decisions that we're going to be making off of it. So I'll turn it over to Jen to cover some of the pitfalls.
Sure. So, these are the patterns we've seen that create challenges for synthetic data. The first is having a scope that's just too broad. So organizations that are making progress in this area, they're not trying to solve for everything at once. They're really solving one problem well and then building from there. So it's best to start with a narrow, testable use case. The second pitfall is not having sufficient real-world trading data. So synthetic models, they shouldn't be creating insights from nothing, right? They're learning patterns from existing data. So if the underlying data is outdated or if it doesn't exist, then the synthetic output won't solve for those problems. We've also found that highly complex studies can be difficult places to start. So the Echo Index doesn't work on advanced analytics such as max diff and conjoint. So our recommendation is to start with core insights and KPIs, establish confidence in simpler use cases first before moving into more complex applications. And then evaluation matters and it should be independent. The creation of synthetic data should be separate from its validation. That's how you build confidence in the data. And if there's one theme that connects each of these pitfalls, it's that organizations often run into challenges when they try to tackle the most difficult problem too soon. So that's why our recommendation is to solve the easier problem first. Build a strong foundation, validate performance, and then use independent evaluation to build confidence before you scale synthetic insights.
So with that, we just wanted to call out a handful of other items that are coming through the pipeline here. First of all, we are going to be releasing a white paper that will summarize more of the technical components beyond what was shared today about the index itself, and some of the details so that everyone can have a better viewpoint of the way we're applying this, what we're using, and draw your own conclusions about the validity of the Echo Index itself. And ultimately, if you are exploring and experimenting in the synthetic data space and you're interested in having your data scored with the Echo Index, or as a provider interested in having some of your models scored against some of these data sets we talked about, go ahead and reach out to us. LinkedIn is up here, or you can find our emails as well, and ultimately be able to have a conversation about using this on your data the way that we've used it in these particular cases. So with that, we'll go ahead and open it up to Q&A.
Sure. So,
Go ahead, Jen.
yeah, as a reminder, Q&A is at the bottom of your screen. So a few questions already came in, so I'll start going through those, but please feel free to submit any additional questions. The first question, is there inherently any bigger gap in synthetic promises versus results if you're considering digital twins versus synthetic personas? Or do you see them as equally gapped from the promise to the reliable results?
That's a good question, and I think here it's really a difference in terms of what you're trying to accomplish. So they do similar things, right? Both of these models enable you to go outside of the training context, learn new things, and address questions that we really can't validate. So it's a leap of faith regardless. I do think that with digital twin models, they can disguise a lot of sins because the outputs can look just like real data. However, with the fact that they were synthetically generated, it's more challenging to understand if the quantitative results that we can derive from them are valid. Whereas I think we all have a pretty good understanding of having a chatbot conversation, which is ultimately similar to a synthetic persona, except it's a very, very, very finely tuned chatbot on specific context. And so, from that perspective, it just can be more obvious with the engagement model there that a synthetic persona is more directional. However, we would argue that both outputs from both of these models are directional in that sense. So I don't think there's a difference in the gap. I think it's just more so a understanding of how the tech is applied and not hiding things that aren't necessarily real by the way the data is produced.
Great. Great. This next comment says, this may be an oversimplification, but how is sample boosting any better than weighting data?
It's a good one. We actually had thought about including this as a slide in the original presentation, but thought it would take too long. And the reason being, this is a question we get all the time, right? Why is sample boosting even a thing? Why don't we just apply weights? And ultimately, the difference is that sample boosting enables novel information. So we are not just taking and copying and pasting the data below and doubling our sample size by taking an exact copy, which would just be the same as applying a weight of two, right? Ultimately, what we're doing here is we are using predictive capabilities to generate what would have happened if we talked to more people. And so we get more of that distribution and more of that coverage in what the responses would look like across new respondents versus just weighting itself. So that's a really common misconception that sample boosting is fancy weighting. It's ultimately sample boosting is ultimately getting us more data that we didn't have before that allows us to potentially enhance the way that our models perform or to get us readable views on segments that we otherwise would have had to ignore.
And then do you have any guidance on how large does a niche sample have to be to create a reliable synthetic data boost?
That's a great question, and it ultimately comes down to a couple factors. So we don't have rules of thumb in general when it comes to sample boosting from the work that we've been doing. Ultimately, we know that if your data set overall is around 75 or larger, then you can at least try. And because of the echo index and the evaluation that we've introduced, you can always verify or validate if the synthetic data boost worked based on whatever that specific data set is. So there's no longer ambiguity in terms of will this work or does this work. It's more so I can test it with some risk, knowing that if ultimately the scoring comes back poor, we just need to pivot or make, more of a directional decision when it comes to that.
Great. What was the biggest surprise you uncovered in development of the Echo Index?
So ultimately, we never sought out to build a governance strategy. We sought out to figure out what synthetic data was, how it would work, and ultimately be able to help answer the questions that our clients bring through modern techniques. As we were going about doing this, the Echo Index itself was probably the biggest surprise because we continue to find this lack of transparency, a lack of rigor, and a whole lot of promises about the way that synthetic data was going to revolutionize the industry until we started digging in ourselves. Because ultimately, as a data scientist and statistician, I'm not going to recommend anything that I have not been able to understand and validate independently myself. And that's where the Echo Index came from. It was ultimately the need to build this kind of governance so that we as an industry can just have a clearer picture of where synthetic works and where it doesn't.
Are there any specific industries or topic areas where you have had greater success with synthetic data?
So that really depends on the model itself, right? If we're talking about deep learning, machine learning, those models don't care if it's a B2B sample, if it's a huge consumer study. Ultimately, they are using statistical techniques and pattern recognition to be able to reproduce data that stays within alignment with the real data it's trained on. When we get to LLMs, that's when the specific audience starts to really matter. And that's where we need to be really, really cautious about things like bias in underrepresented groups and the way that we are training those models to be able to address a specific problem. And so ultimately, I think we'll start to see and build a better understanding of the specific audience and how well they perform as we get more and more into evaluation of digital twins, where we need LLMs to be able to successfully address those types of learnings that go outside the training context window.
Okay. Somewhat related, but one question is, have you seen or do you expect greater success with consumer sample versus B2B?
And so I think it really goes back to some of that data size in general,
Hmm.
especially if we're using traditional techniques. Where B2B, we would expect to have a smaller sample. We can tend to see higher quality data in B2B simply because we have higher incentives, more rigorous screening techniques, and so it just depends on really the data quality itself. And if you have quality sample, what we found is that too much data can be a problem when it comes to building synthetic. But also, if you have too much data, then why are you running synthetic in the first place, right? So it kind of begs the question of what are you trying to solve? And is synthetic the solution? Or is synthetic just something that you've heard about and you want to apply because you need to check a box? And so just be really careful about when you're using and applying these different techniques.
Great. All right, we're at 45 after the hour, so I think that brings us to time, and we've got through most of the questions. Thank you, everybody, for spending time with us today. Thank you for your participation. We hope you enjoyed it and found the discussion valuable. Please reach out to us via LinkedIn or KS&R's website. And you have any closing remarks?
I just appreciate everybody joining, and I'm looking forward to hearing everyone's feedback as we try and figure out how synthetic is going to be impacting industry. Thanks for joining.
Great. Thanks, everyone. Bye.